We are going to talk about classful IP addresses in this video. So classful IP address is only applicable for IPv4 and this is no longer in use. This is replaced by CIDR, but I still think this is useful to learn. We know that the IP address is hierarchical. This means we'll be using some higher order bits for the network and the remaining bits will be used for the host. We need this structure for efficient routing of IP packets over the internet. So in the very beginning of the internet, this hierarchy had a fixed structure. So we had 8 bits for network and the remaining 24 bits were used for the host. This means we'll have a maximum of 256 networks and each of those networks can have 2 to the power 24 hosts within them. If you think about this is very limiting, as we know that internet is made up of several small networks. But if we say that you can have maximum of only 256 networks for the internet, then this is not sustainable, right? Because internet was growing at a faster pace and just having 256 networks for the entire internet is not scalable at all. That will be very limiting. And the other problem is each of those networks are going to be huge network because each of those network can have 2 to the power 24 hosts within them. And in most cases, we will not have such a huge network. Even though we will not have those many hosts within those networks, which means we'll be wasting so many IP addresses. We know that the IPv4 has maximum of 4.3 billion IP addresses, right? So if you are wasting so many IP addresses in each of these huge networks, then we'll be depleting the IP addresses at a faster rate. So IP depletion will be at a very higher rate. So we needed a solution for this. We cannot keep the structure like this. We need a better solution for this. And people initially came up with a plan to introduce something called classful IP addresses. Okay, so they have introduced 5 classes A to E. And what they have done is they have fixed prefixes for each of these classes. So we know that the IP address is made up of 32 bits. What they have done is they have taken the first few bits of those IP addresses and they have fixed them for each of these classes. So if any IP address that is starting with 0, as in the first bit being 0, will belong to class A. And also anything that starts with 10 will belong to class B. And 110 will be class C. 1110 will be class E, and for class D it will be 1111. So this is the fixed prefixes they had for each of these classes. This means we also get the range for each of these classes. Just by having fixed prefix will automatically give us the range, right? So for class A, the range is 0.0.0.02 127.255.255.255. Okay, so this is the range for class A. And similarly, we had range for class B, C and D. So for class C, it will start at 192.0.0.0 and it will end at 223.255.255.255. So we have this range for each of these classes. And only the first 3 classes, class A, B and C, are used for normal networking. Class D is used for multicasting and class E is reserved for future use and research purposes. So for class A, B and C, we had fixed structure for network and host bits. Okay, for class A, we were using 8 bits for network and 24 bits for host. And for class B, we were using 16 bits for the network and the remaining 16 bits for the host. And for class C, we were using 24 bits for the network and 8 bits for the host. Okay, now rather than just having 256 networks where each of the networks being very huge, we have 3 different structures to choose from. If we want a huge network, we can choose an IP in the class A range and we can go for the huge network. For example, in class A range, we have IP addresses starting from 0 to 127. The first 8 bits can vary from 0 to 127 because first 8 bits are used for network, which means we could pick anything like anything between 0 and 127 for the first 8 bits and that will become your network. For example, if you have chosen 25 as your first octet, then you can have IP addresses in that range. For example, 25.0.0.02, 25.255.255.255. So this will be your network IP range, right? So you'll still be able to have huge network, but this time they have reduced the number of huge networks you can have. Rather than having 256, you can only have 128 such a large networks. Similarly, for class B, we are using 16 bits for the network and 16 bits for the host, which means we'll be having a medium size network. And if you want a small network, for example, you can choose a range from class C, and each of the networks in class C can have maximum of 256 hosts. Okay. Now, this will help to some extent avoid depleting IP addresses at a faster rate. We'll still be wasting some of the IP addresses because, let's say, for example, we have chosen this class C network where we have 256 IP addresses allocated for hosts, but we may not have 256 hosts in that network. In that case, we'll still be wasting some of the IP addresses, but this is much better compared to just having one fixed structure where we have 8 bits for the network and the remaining 24 bits for the host. Okay. And you also need to remember that all of these are happening before NAT. In the present days, we use NAT to avoid allocating unique IP addresses for each of the devices in the network. But I'm talking about all these things before the introduction of NAT, which means each of the devices, even within the network, needs to have unique IP addresses across the internet. Okay. So although this was working slightly better than having just one structure, this is still not good enough, right? Because we are still wasting IP addresses and the structure is still rigid, right? You cannot choose any arbitrary sized network. You have to go with one of these three, and which means we'll still wasting the IP addresses. So the better solution for this to allow having arbitrary number of bits for the network, right? You can choose 3 bits for the network or 25 bits for the network. You can choose any number of bits for the network. That will be much more flexible. And that was introduced little bit later, and that is called CIDR. So CIDR means classless interdomain routing. So essentially, CIDR replaced classful IP addresses. In the present days, we only use CIDR. Okay, so we are not using classful IP addresses anymore, and that is replaced by CIDR. I hope this is useful. Thank you.